with bivariate data, we know that we're dealing with two variables. We've already talked about the fact that we have the explanatory variable and the response variable. And we know that the explanatory variable will go on the x-axis and the response variable goes on the y. Remember, explanatory is like the independent variable, so in excess. Now, the best way to display bivariate data is to use this thing called a scatter plot. And now that we are going to draw up a scatter plot, we know what we need to put on each axis. So let's have a look at this example. The marks students obtained in an examination and the times they spent studying for the exam. We need to work out which is the response variable and which is the explanatory variable. So what was the question that we asked ourselves? What depends on what? Does the time you spend studying depend on the mark you get? Or does the mark you get depend on the amount of time you spent studying? This is very obvious. The mark that you get depends on the time you spend studying. So therefore, mark will be your dependent or your response variable, and time spent studying will be your independent or your explanatory variable. So now that we've worked out both of our variables, what we can do is set up our axes for our scatter plot. Now, a scatter plot is basically just a graph with a x and y axes, if you like. And like all graphs, it needs to have a heading. So what is this data about? Well, it's the marks obtained in an exam and the time spent studying. So how would we sum that up? So I've simply called it the marks versus the time spent studying. Now, we've already worked out the response and the explanatory variable. The response variable was the marks and the explanatory was the time in hours. So we know that the explanatory went on the x-axis. So I'm going to put time on the x-axis, and that is in hours. And I'm going to put mark on the y-axis, and that is a percentage. And now we need to think about a scale. So if you have a look at time, the biggest time there is 36. So I'll probably go up to 40. Our highest mark there is 87, so I probably need to go up to about 90. The scale that I'd probably use there would be tens as well. All right, our axes is set up. We've labelled our graph, we've given it a heading, we've got good scaling happening. Let's see if we can't plot this now. So the first lot of data there says that when the time was 4 hours, the mark the student received was 41. Let's plot that on our graph. So 4 is around about here, 41 is around about here. Where do the two meet? At that point there, so that's where my dot goes. Okay, so it's just where they intersect. The next one is when time is 36. So 36 would be around about there, and 87 is around about there. So when I line them up, that's where my dot is. And now I have to plot every other pair. So 23 and 67. So there is our scatter plot. Now it's the dots that we're interested in. You don't have to go through and label each of the points like I've done there. I just wanted to show you exactly where each of the points from our table were. Now let's just look at that scatter plot before we move on. Can you see that as the time in hours is increasing, overall, what's actually happening to a student's mark? Can you see that that is also increasing, and that's quite visible from our scatter plot because it's going upwards with a positive gradient. Now here we have the instructions for how to put a scatter plot into our calculator, and although you may be able to work through them quite easily, we will be having a look at this example and making sure that we are putting it into our calculator properly during class time. So have a look at these instructions first, see whether you can work it out, and bring some questions to class with you.